Welcome back to NextEd presented by Nexaspaces. You've just entered Module 4 of our Embedded Systems series, Programming for Embedded Systems. In this module, we'll unlock the software side of hardware, exploring the world of embedded C programming, and how to bring life to microcontrollers using the Arduino IDE. Whether you're building smart devices, automation tools, or just getting started with embedded systems, this module is your foundation. Before we get into code, let's clarify, what exactly is embedded programming? Embedded programming is the process of writing code that runs directly on hardware, like microcontrollers, to control machines, sensors, displays, motors, and more. It's not just programming, it's programming with purpose, to interact with the physical world. We use embedded C for its efficiency, predictability, and close-to-hardware capabilities. And with the Arduino IDE, we make development more accessible and visual, a perfect entry point for anyone new to embedded systems. Let's start with the basics: loops, conditions, and functions. Loops let your code repeat tasks, ideal for reading sensors or blinking LEDs. You'll work with for, while, and do-while loops. Conditions bring logic to life. Using if, else if, and switch, we make decisions based on inputs, like turning on a fan when temperature rises. Functions help organize code, improve readability, and allow reusability. We'll show you how to define and call your own functions to keep your programs clean and modular. These are the ABCs of embedded logic, and we'll walk through practical examples so you see how they work in real devices. In embedded systems, timing is everything. You'll learn how to use delays to pause execution, useful but risky when misused, as it can freeze the program. That's why we introduce timers, internal counters that track time without blocking the rest of the code. With timers, your device can blink an LED and read a sensor simultaneously. But what if you need your device to respond instantly, like stopping a motor when a button is pressed? That's where interrupts come in. Interrupts let your microcontroller pause its current task to address an important signal, then return to where it left off. We'll show you how to configure interrupts and timers, with real-world demos to help you master time-sensitive tasks. Now let's talk about communication. Devices need to talk to each other, and that's where serial protocols come in. You'll learn 3 key ones. UART, Universal Asynchronous Receiver Transmitter. It's a simple, point-to-point communication often used for debugging or connecting modules like GPS or Bluetooth. I2C, Interintegrated Circuit. This protocol allows multiple devices to communicate using just 2 wires, ideal for sensors and displays. SPI, Serial Peripheral Interface. Fast and reliable, great for high-speed data transfer between microcontrollers and memory chips or screens. We'll explain how each protocol works, their strengths, and how to implement them with real components using the Arduino IDE. You'll learn to send data, read values, and even debug using serial monitors. Writing code is just part of the process. Next comes flashing, uploading your program to a microcontroller. We'll show you how to use the Arduino IDE to connect, compile, and upload your code. It's simple once you understand the flow, but things can go wrong. That's why we'll also teach you troubleshooting techniques. Checking COM port connections. Handling compilation errors. Fixing common logic mistakes. Using serial print debugging to trace values. Troubleshooting isn't just about fixing bugs, it's how you learn to think like an embedded engineer. This module is your bridge from theory to practice, turning abstract logic into real-world action. By the end of Module 4, you'll be able to write embedded C code with confidence, control devices through logic, timing, and communication, build robust systems ready for real applications. So get your hardware ready, and let's build something amazing. Don't forget to like, subscribe, and turn on notifications so you don't miss any part of this series. You're learning with Nexaspaces, powered by NextEd, Nexaspaces Tech Education.